My name is Laura Kahn, and I'm excited today to be talking about research that's never been done, using data visualizations to quantify the relationship between coffee rust, production, and futures prices. Today I'll be talking about why I'm doing this project, its scope, how existing research is related to my project, the data acquisition process, the data analysis process, and how I chose to present the results. Did you know that we consume more than 2 billion cups of coffee every day, or that the livelihood of 120 million people depend on the coffee supply chain? I chose this project because the impact coffee has in our lives, and also because coffee is the second most popular traded commodity, worth over $100 billion annually. But coffee is in trouble. Coffee rust is a disease that causes more than $500 million in production losses each year. I'll be describing my visualization process to look at quantifying links between coffee rust, production, and futures prices. 75% of all coffee produced is the Arabica variety. Brazil, Colombia, and Papua New Guinea produce almost half of the world's coffee supply, so data from these three countries was included. Even though my project has never been done before, Regressions's research led me to include temperature and rain variables in my analysis. Yap's research differs from mine in that he doesn't include any weather variables to predict futures. Avellino's research does not provide a quantitative link between rust and prices like I'm attempting to provide. My analysis will try to accept or not accept the following hypothesis. More rain increases rust, higher temperatures increase rust, more rust decreases production, more production decreases futures, and more rust decreases futures. Before I talk about the data acquisition process, I wanted to mention my data was in the public domain and didn't contain any personal identifiable information. Therefore, the data reuse does not violate any ethics principles. Before I start describing the data, it's important to note there are gaps in available data. Brazilian data was from 2005 to 2006 and 2008 to 2009. Colombian data was from 1995 and 2011 to 2013. And the Papua New Guinea data was from 1989 to 1991. Since the growing conditions in Brazil, Colombia, and Papua New Guinea are similar, it is acceptable to compare data between these three countries. Percent rust on plants was calculated from yearly statistics. Futures are worldwide prices rather than by country. Finally, I assume the public data is accurate. There were 337 observations of the following variables: monthly rainfall, monthly temperature, percent of rust on the plants, monthly production amount, and biweekly futures prices. There were a few challenges to get the data. I needed to learn about coffee and futures quickly to find the data. Some documents had to be translated, and there were more than 10 different data sources that had to be combined. Next, I want to describe a few data cleaning steps. The date variable was reformatted. All numerical values were rounded to 2 decimal places. The temperature variable was renamed, and country names were spelled as they would be in their native language. Next, from the data acquisition process, I'll talk about the first step in the analysis process, getting summary statistics. This table shows the minimum, maximum, mean, standard deviation, as well as the 25th, 50th, and 75th percentiles for each variable. Next, I created 3 histograms that show the distribution of rust, production, and futures in separate graphs. Coffee production peaks at 1,000 and then 3 to 4,000, measured in 1,060 kilogram bags. Coffee rust peaks between 5 to 20%. Coffee futures peak around 30 and 140 US dollars. After seeing how the variables are distributed, let's talk about a correlation matrix visualization, where each variable is represented as a square. Variables that are positively correlated change in the same direction, and variables that are negatively correlated change in the opposite direction. Rain is negatively correlated to rust. Temperature is negatively correlated to rust. If rain increases, rust decreases. If temperature increases, rust decreases. Rust is positively correlated to production, so if rust increases, production increases. Production is positively correlated with futures, so if production increases, futures increase. Rust is negatively correlated with futures, so if rust increases, futures decrease. Returning to the original 5 hypotheses, I can only accept the last hypothesis, that more rust decreases futures, using this correlation visualization. Line plots show relationships between the variables. Rain and temperature are not included since the correlation matrix showed they don't impact rust or futures. From the first two line plots, rust in production and rust in futures may be correlated to each other, but it's difficult to say. For rust in futures, a scatter plot was used rather than a line plot, but this relationship is difficult to see. After the line and scatter plots, I created a linear regression visualization between percent rust and production. This plot shows an increase in rust means an increase in production. I failed to accept the original hypothesis that increase in rust means a decrease in production. This visualization shows production and futures are positively correlated to each other, meaning an increase in production equals an increase in futures. I failed to accept the original hypothesis that an increase in production would mean a decrease in futures. Linear regression did not fit the rust versus futures data, so I used a polynomial fit. There is a positive correlation between the variables, which is the opposite result of what we saw earlier in the correlation matrix. Let's examine this more carefully to see if this original hypothesis should be rejected. The regression of rust versus futures has the opposite correlation of the original correlation matrix. Rather than a linear regression that did not fit the data, I used a polynomial fit that minimizes the square error. I calculated the root, mean, standard deviation, and slope. If we look at the data, we see large differences between the x variable rust and the y variable futures. These variations explain the difference between the regression plot and the correlation matrix. The original hypothesis that more rust decreases futures must also be rejected. Communicating information visually is a big part of this project, so I'm going to describe some of my failed experiments. I initially wanted to use a chloropleth map showing production amount for each country, but then realized this would highlight only one variable rather than the relationship between the variables. The next failed experiment was adding a calendar view where a user could hover over a block on the calendar to see that day's future price. Again, this visual was not included since it would not emphasize the relationship between the variables. The final visualization that was not added was an interactive line plot of futures over time. If you recall from an earlier data acquisition slide, there were gaps in years of the data, so interpolating futures during the missing years would be misleading. I wanted to communicate my findings in the research between coffee rust, production, and futures. It's important to include the source data and visualizations and that they were publicly available. I had to choose between manually creating an HTML web page or using a JavaScript WordPress template. The template was chosen because you can more easily add slideshows. It follows current web standards for presenting information. It automatically scales content based on a user's device, and it is a publicly available website. Reproducible and high-resolution images that were freely available were chosen to clearly communicate the story of rust, production, and futures. Images were used to create rotating slideshows in 2 of the web page sections. In addition to using existing static images on my web page, I modified several administrative maps for each country in the project to highlight regions that show coffee, shown in dark brown, and regions that don't show coffee, shown in light yellow. An appendix with the interactive box plot visualization of rust intensity and futures was added. If you hover over a box, the minimum, average, and maximum values will appear. The visual is tangentially related to the project, which is why it was added as an appendix. The correlation matrices, line plots, and linear regression visualizations are used to validate the original hypotheses. The first hypothesis, that more rain increases rust, I failed to accept. The second, that higher temperatures increase rust, I also failed to accept. The third, that more rust decreases production, I failed to accept. The fourth, that more production decreases futures, I failed to accept. And the fifth, that more rust decreases futures, I also failed to accept. Thank you for your time and attention, and I look forward to hearing your feedback and getting more ideas on future research. Thank you.